Namaskar, welcome back. So this was the last part we were discussing on the that how the intraplate earthquakes can be more damaging as compared to your uh, interplate earthquakes. Okay, even though the magnitude is not very large actually. Now, further earthquake hazard and risk, if we talk about, then the hazard related to earthquake is anything associated with an earthquake that may affect normal activities of the citizens. This includes surface faulting, ground shaking, landslides, liquefaction, tectonic deformation, and tsunamis. And the risk part is basically the most important because most of the people they are killed, they are because of that is because of your building collapse, okay, and poor construction. So people that are expected to be hurt or killed if an earthquake is likely to occur on a particular fault. So that will be a risk part. Now measuring earthquake, coming to that, because this is also again an important part, and uh, we have prepared a lecture. This is which take you back into the history and what were the scales which were been used, how the earthquakes were been measured, and now what is the present scenario. Okay. So earthquake usually has been measured based on the intensity, that is the ground shaking, and the energy released, that will be your magnitude. Okay. So intensity is the representation of effect, that is your ground shaking and damage pattern in particular of by an earthquake at a particular place based on the observations of the affected areas. So usually when there were no instrumentation facilities and the instruments were not been deployed uh, in more numbers, then usually we used to look at the pattern, damage pattern, and based on that the isoseismal maps were been generated. Now this before the magnitude came in, uh, the intensities were been assigned in Roman letters, okay, or Roman numbers we can say, and that was been termed as Mercalli scale. Or, and in terms of the magnitude, what we do is that we try to measure the energy which has been released, and that has been done as we have learned in one of the lecture, that we take the amplitude and the difference between the arrival time, okay, of the surface waves or the body waves, okay. And this magnitude scale is in numerical numbers 1 to like you can go up to 9.5 or 10, because 9.5 is the maximum or the earthquake which is measured on this planet, okay. And this has been termed as Richter scale or Richter magnitude. Now the first seismograph, this was invented almost like 2000 years back by Chinese astronomer, and this was been termed as earthquake weathercock. Okay. Now this uh, seismograph is having an sort of an a brass vase, and it has 8 dragons with bronze balls in its mouth. So whenever there was an even like slight tremor, a mechanism inside the seismograph would open the mouth of one of the dragon, and then the bronze ball will fall into the open mouth of the frogs which have been sitting at the base. Okay, and so that will also make some sound. Okay, so that will alert uh, the scientists or the people who are uh, assigned to that laboratory. Okay, So it was even possible to tell that from which direction the earthquake seismic waves are coming in. Okay. So that also they will be known, and this was been done like 2000 years back. Okay. Now, if you look at the chronology of the intensity in the magnitude scale, then before 1931, earthquake intensities were often reported using cruciform scale, and in the last quarter of 19th century, the use of intensity became widespread. And this scale was developed by Italian and a Swiss scientist, and that's how this was been named as Rusifural scale. Now, this scale was called Rusifural scale with 10 degree of intensity. That means in Roman letter 1 to 10. Okay. This was the first scale to be widely used internationally. So this is coming from Europe. Okay. Now, the scale of that is Rusifural that has been shown here, that what will be the intensity 1, microshocks recorded by single seismograph of the same model, the shock felt by an experienced observers. Okay. Then 2, extremely feelable, very feelable, 3, feelable shock. Okay. That felt by that is for 4 intensity, felt by persons in motion, disturbance of movable objects, doors, windows, cracking of ceilings. Okay. And so on. So this is what has been based on the observations, the scale was been prepared and it was been used. So wherever you see a damage pattern which falls within the domain of the respective intensity, then that intensity will be assigned to that region. Okay. So then we have extremely feelable 9, and then we have 10 shocks of extreme intensity, great disaster, ruins, like a lot of the constructions or maybe the buildings or the houses will be shattered and damaged, and disturbance of the strata, that is your uh, uh, sediments or rock stratus, we can say that. Okay. Fissures will be developed in grounds, rock falls, that landslide, it will result in the mountainous areas and all that. So this is the maximum intensity of 10 we have. Now, next phase which came up, the scale was improved by Mercalli, who published a modified version still with the 10 degrees. Okay. However, even this 10 degree were insufficient for expressing the whole range of effects, that is a damage. Okay. So the extension of the scale was been done to 12 degrees. Okay. So initially it was 1 to 10, and then it was been raised up to 12, and was therefore proposed by Kankani. Okay. Then it was named as modified Mercalli scale, and this is in short form acronyms, it is scale. So further modification, if you look at, then this was been maximum intensity you look at, and then what is the modified Mercalli intensity, it has been given up to 12. Okay. The total damage, if you see the total damage, then you may assign 12 intensity for that area. So this is in the effects which has been given the description. So usually people used to have this description with them when they visit the field, and they try to assign the areas with a particular intensity. Now, this was an earthquake. For example, we are looking at the mesoseismal zone of 1905 Kangra earthquake. The magnitude was 7.8. It was total damage, okay, in this area. And the intensity map, if you look at, then this was the intensity map which was been produced at that point of time. And intensity was not so high actually then also. If you compare it, it was up to almost 7. Okay. And this area probably, yes, of course, must have the higher intensity in the Kangra region. And then there was an effect of the higher intensity which was observed in the Dehradun region also. Still, there is a question which has been raised that why this happened. It's not completely understood. Okay, but overall, if you look at, then as you move away from the epicentral area, then the intensity reduces. Okay, so like areas which are coming here in Gujarat, okay, and then further going to Kolkata and all that, the intensity was 1, 2 to 3. Okay. So this was the damage which was been reported uh, of one of the church in Kangra region, and this is close to McLeodganj. And the right hand side photograph, if you what you see is after uh, it was been repaired, okay, or restored. Now, isoseismal maps, usually these are the maps which have been prepared based on the observed effects of ground shaking. That is what is assigned as an intensity, and very much similar to what we produce is the contours based on the height, okay, or the elevation. Similarly, this type of maps are being prepared considering that which areas had similar type of damage and had experienced the intensity. Okay, so in some areas the intensity may be higher. Okay, and that is what we will learn in near like in coming lectures. That is what we call site effects. Okay, that the intensity of ground shaking in the epicentral area was comparatively less than the areas which are sitting away from that. Okay, that has also been experienced. So it is not always we should take as a blindfold that the intensity will reduce as we move away from the epicentral area, because that is the area, the epicentral area is the area where maximum energy has been released. So ground shaking is expected to be very high there. But some regions, because of uh, the change in the geology, what we call the lithology, type of material, the amplification may vary, okay, and may experience higher amplification as compared to, or ground shaking as compared to your epicentral region. This is of Bhuj earthquake 2001, the intensity map, and we can say that based on the intensity, the isoseismal map was been developed. Okay, so just remember what is the difference between the isoseismal maps and the contour maps. Okay, they are similar, but the contour maps are based on the information which we put on the elevation and height, and in terms of the isoseismal maps, we take into consideration the pattern, similar pattern of damage which has occurred, that is related to the intensity of the ground shaking. So this is another map which has been which was produced based on the damage pattern which that was experienced after or during, we can say, during the 2001 Bhuj earthquake. Okay, so the intensity was up to like 10 here, and then further if you move it reduces to 8 or so. Okay, and then in this area it was 7. So this was pretty uh, large shaking we can see which was experienced uh, even areas which were sitting far away. Okay, and not only that the extreme damage was been experienced, a total damage we can say in the areas like uh, Bhuj and nearby regions of Kutch, or nearby villages of Kutch or cities of Kutch, but even the city like well developed city like Ahmedabad got affected because of strong ground shaking, and that was because of the site effect. There's another isoseismal map of 2005 Muzaffarabad earthquake, which was experienced right up to like your Ambala and all that. Okay, so this was around 4. Okay, and liquefaction, farthest liquefaction we reported in one of our research article, the farthest liquefaction which was observed, that is related to your ground shaking. We'll come to that part also, what is liquefaction and all that. That was up to Jammu region. Now, magnitude scale, if you take, okay, several magnitude scales are widely used, and each is based on measuring this specific type of seismic waves with a specified frequency range, okay, and with certain instruments only. Because some of the instruments will not be so, we can say that to measure the frequencies which have been generated by during the earthquake. Okay. And then scales are been commonly termed as, using surface wave for example, it is termed as MS, and the Richter scale is been termed like it has been given as ML. Okay. And then later on, scientists also tried to use the body waves. Okay. And those magnitude scales were been termed as MB, or and even the moment magnitude. Most acceptable and widely used now is your moment magnitude. We'll come to that part also, what is moment magnitude and all that, and how they have been taken into consideration. Now, seismologists developed different methods to record the size of an earthquake, because sometimes what happens that a large amount of energy has been released, but because of the limitations of the instruments, are unable to measure, or are not sensitive to those frequencies, you may undermine uh, the earthquake magnitude, okay, the size. So based on the body wave which travel deep within the interior of Earth, they use that also, and as well as the surface wave, okay, which travels along uppermost layer of the Earth. Okay. So this part we had a brief discussion that initially the local magnitude uh, was been used, okay, and that we termed that is a Richter magnitude scale, okay, and this has been termed as ML, and this was been measured mostly by Wood Anderson torsional seismograph, okay. So can record on a special type of seismograph. This is termed as that, okay. And Richter magnitude scale can even measure if you drop a brick from a tabletop, okay. That can also, it was sensitive, but it has limitations, okay. So this instrument has limitations to measure large magnitude earthquakes, okay. Or we can say the earthquakes which are occurring far away from the epicenter. It will not give you the correct magnitude, okay. And because of again the frequency of waves, it was not sensitive to that, okay. So the low frequency waves will travel farther distance, and that was not possible to be measured by such instruments, okay. So it gives an accurate energy released by locally within the range of like 100-200 kilometers up to 6.5 magnitude. However, the locally it can also measure up to greater than 8 magnitude. The largest earthquake recorded was Alaska in 1964 with a Richter magnitude of 8.6. Now, as we told, we see that this is like it has some limitations. So, seismologists used a magnitude scale to express the seismic energy released by each earthquake. So this is a comparison between the intensity and all that, which has been done, which goes up to like 8, where we can classify this as a great earthquake. Okay, now above 8 magnitude, And as I told, that the largest magnitude which has been recorded on this planet is 9.5, 1960 Chilean earthquake. Above that, we haven't measured till date. So Indian part, if you take, so we have areas which have potential to trigger 8 magnitude earthquake up to 8.5, that is Himalayan region. And in the Andaman area, if you go, we had 2001, which was 9.2 to 9.3 magnitude. Okay, so we have great and mega subduction zone earthquakes which are experienced by the Indian region. Okay. So modified Mercalli intensity scale and Richter scale, if you look at, then this is what they have compared with. Okay, you're having the intensity as well as the magnitude which has been given. But as we have discussed that there were limitations with the instruments. Okay, so more refinement were been done, different scales were been used, and then finally arrived that okay, fine, this scale is the best one which should be used. And so this is one of the the photograph of the seismic station in USGS site. This was, if I'm not wrong, from Seattle, which shows the recording of the earthquake which has been taken up by such instruments. Okay. So this is a close-up of that. So these are all small magnitude earthquakes which are occurring over that area. Okay. Now, just to have an example, this is the area again from where you have an active volcano in US, that is Mount St. Helens, and there is an observatory which has been later on after the eruption which took place in if I'm not wrong, 1980s. They developed this. Okay, so this they keep on recording the micro earthquakes also in this observatory, and this all you can see this is the all on graph. What you see, the blackish lines are the micro earthquakes. Okay. Now, limitation with the Richter scale. New scale to measure large magnitude earth, because large amount of energy has been released, and distant earthquakes, what we call teleseismic stations, okay, were developed. Surface wave magnitude came up, and then the body wave magnitude also. But even with this magnitudes, there were limitations. Okay, limitations with measuring the magnitude as well as the instruments limitations. Okay, so surface wave magnitude scale becomes saturated at around 7.3. So if an earthquake has occurred which is more than 7.3 or 7.5, then this scale will not work and it will undersize the magnitude. Okay, body wave again about 8, it becomes saturated. Okay, then it was been decided that why can't we have instruments which are been placed and they are sensitive to have the measurements in terms of the including the information of the active faults and all that. Okay, so later in 1966, Aki proposed a new scale, and that was seismic moment, MO. Okay. Energy released from the entire fault rather than an assumed source of point was taken into consideration. So the energy is released. So you have multiple stations, and those stations are measuring your the energy released in, and that is your amplitude and all that. Okay, so definition of the seismic moment you take, then you have where this is mu is the shear modulus of elasticity for crust. Okay, and then U bar is your amount of slip along the fault which has been taken into consideration, and S is your surface area that ruptured during an earthquake. Okay, where you take the length and the depth. Okay, so that will give you the surface area. So this scale, it came up, okay, and later more refined scale was proposed by Kanamori related to seismic moment known as moment magnitude scale, and this has been given as, now this has become like worldwide, this has been used, moment magnitude. So if you have the seismic moment, then with the empirical relation which has been given here, you can calculate easily your moment magnitude. Okay, that is MW. So you need to have the MO, which we have discussed in the previous slide. Okay, now this scale is been used worldwide for measuring moderate as well as large magnitude earthquakes. Okay, so we'll stop here. I'll continue in the next lecture discussing more on the magnitude, and then we will also briefly touch upon the ground acceleration part. Thank you so much. Namaskar.